All right, y'all. So we're at the product rule, correct? And we did everything else. Oh, hang on. What's the derivative of 3x cubed? 9x squared. Do we agree? How about 4x squared? What's the derivative? And how about the derivative of 4? Why is that 0? So what?
It's like x to the 0.
It's like x to 0, and this is a horizontal line, right? What's the slope of a horizontal line? 0. And what is a derivative, just conceptually? What?
It's the slope of a tangent line at one point.
The slope of the tangent line at a single point. Cool, exactly. Which is why the derivative of a constant function is 0, because the slope at any point is 0. Cool. Okay. And now we're going to try to differentiate more difficult functions, specifically the product of two different functions, okay? So if you have two functions being multiplied together, f of x and g of x, then the derivative is the first function times the derivative of the second function plus the second function times the derivative of the first function. Does that make any sense? And there's a rhyme. 1d2 plus 2d1. That's not a rhyme. It's just kind of a little mnemonic. So 1 as in your first function, d2 as in the derivative of the second one, plus 2, your second function, d1, the derivative of your first function. All right, does that make any sense? So the derivative of example 1, 3x times x plus 1. Using this handy little formula, we can say the derivative, y prime, is equal to our first function. Maybe we should call one of these f of x and one of them g of x. Does it matter which one we pick to be which one? No, to be multiplied. So what do you want f of x to be? 3x. And g of x? X plus 1. So we have those functions now. And then we need the derivatives of each of those functions, and then we're good. So what's the derivative of f of x? And what's the derivative of g of x? 1. And that's all we need to find the derivative of the product of these two functions. So the derivative, y prime, is equal to f of x, which is 3x, right group? Times the derivative of g of x, which is 1, plus our g of x, which is x plus 1, times the derivative of f of x, which is 3. Then we can simplify a little bit because 3x times 1 is just 3x, right? And then let's distribute this 3. So we take 3 times x, which is just 3x, and then 3 times 1, which is just 3. And then this just becomes 6x plus 3. And that's the derivative function to 3x plus x plus 1. No, 3x times x plus 1. What questions do we have? Do you want to try the next one on your own? Are we quiet because this doesn't make sense, or are we quiet because it's Friday and we're tired? Okay, so this is kind of making sense.
So the 3x comes from the original f of x, and then the 3 on the end is f prime of x, correct?
Are you talking about this function right here?
Yeah.
This whole part? Yeah, so this x plus 1 is just our g of x. And then this 3 is the derivative of f of x, yes.
And then the 3x is just the original f of x.
Correct. And then this 1 was the derivative of g. Yeah. You want to try the next one on your own, or you want to do it together? Try the next one on your own. I'll do it up here too so you can check your work. Mm. All right. What did we get? That? Yeah. What questions do we have at the moment? Okay. Let's try example 3 and maybe example 4 together. At least get started on them because I'm throwing some harder things at you.
Is this like the simplest way to get it? Like this simple?
This product rule?
Yeah.
That's a good question. Is this the simplest way?
It's like this has a shortcut. Does this have?
Does the product rule have a shortcut?
Yeah.
No. This is a shortcut. We're not going to prove it because that's honestly a little bit beyond this class. I didn't learn the proof until, well, like a year ago. But it uses analysis. I thought your question was, is the product rule always the simplest way to do this? So what was the first one? Wasn't it like 3x times x plus 1? Couldn't we have just said, okay, let's just distribute? So this is really just 3x squared, right? Plus 3x.
Oh.
And then we could have just
Yeah.
done the power rule, right? So what's the derivative of 3x squared?
6x.
Is that what we got? Yeah?
They're both about the same.
About the same? Sometimes one will be easier. Sometimes not. Kind of depends on you. Okay. So this next one, for the sake of practicing the product rule though, let's keep using the product rule. I'm going to change, let's rewrite this as x squared plus 3 times, what's the square root of x written as a fraction exponent? X to the 1/2. All right. So, y prime, our derivative function is our first function, which is x squared plus 3 times the derivative of the second function. What's the derivative of x to the 1/2? Half x to the negative half. If you're not sure about this, I actually have this written on the board from earlier today, the power rule. This is a reminder. You doing okay, Lizzie? We'll get you caught up. Yeah, once you have the first part of these notes. Okay, so this is only part of it, right, class? We just did the first function times the derivative of the second. So now what do we do? Plus x to the 1/2 times the derivative of the first function. So what's the derivative of x squared plus 3? 2x. All right. Be done. Don't simplify it. You can, but honestly, no, because that's where you'll start making mistakes. I would just leave it like this.
Me.
All right, y'all okay so far? You have any questions so far?
So,
Yes.
just a random question.
What's
if
your-
we were to simplify this, what would that look like?
All right. All right, TJ asked. Okay, TJ. So first we would distribute this. So take 1/2 x to the negative 1/2 times x squared. So that's 1/2. X to the 3/2. Yeah, you can just watch.
Yeah, I don't have room for this.
Yeah,
All right, TJ, you go with this?
yeah.
That's 1/2 x to the negative 1/2 times x squared.
Yeah.
Really?
Wait, I don't know. I'm trusting you.
Oh, well,
I'd say so.
because when you have the same base, so like x squared times another x, a base of x to the 1/2, then you add those exponents.
Yeah.
To get an exponent of 3/2. Okay, plus 3 times 3 or 3 times 1/2, which is 3/2, x to the negative 1/2, plus 2x times x to the 1/2. Can you simplify that one for me? 2. 2x to the 1/2, which is 2x to the 3/2, right? Now we've got some like terms, don't we?
Yes.
Those x to the 3/2. So this equals 2.5, so 5/2, x to the 3/2, plus 3/2, x to the negative 1/2, which is 1 over x to the half, which is 1 over root x. So this is 5/2 x to the 3/2 power, plus 3 over 2 square roots of x.
Now we don't do that.
You see how calculus is really just a whole bunch of algebra with a couple new concepts. And those new concepts are really just slope. Yeah.
All right. Well, see, now I appreciate that we don't have to simplify it anymore.
Okay. Let's move on. This one, what is going on? I don't see a product. I see a quotient. I see something divided by something. What's up with that? Why is this in the product rule section? Oh. Alexa says this is really just like saying x squared plus 1 times 1 over x. But do we know how to find the derivative of 1 over x?
I feel like we did yesterday. If we don't, then you do.
I think you typed that into Desmos yesterday.
You think so? I probably did. We use 1 over x a lot in here. Y'all. Do you follow me if I say this is just x squared plus 1 times x to the negative first power?
Yes, so
Are you okay with that? Yeah? Okay. All right, and now do we have a product of two different things? You bet we do. So what's the derivative?
2x. Wait, of what?
x squared plus 1
Of y, the derivative of y. So we take our first function times the derivative of the second one, so x squared plus 1. Say that again? What's the derivative of x to the negative first power? Pull that negative 1 down and then subtract 1 from the exponent. Negative x to the negative second power. Whew. Plus plus 1 over x, or x to the negative 1, sure, times the derivative of x squared plus 1, which is 2x. That's where you got the 2x. And you can leave it like that, or you can simplify by saying this is really just negative x squared plus 1 all over x squared plus 2. Right. And I guess I should put parentheses around this first one. What questions do we have over the product rule?
Is this the easiest rule?
I think the power rule is the easiest rule. Well, actually, the derivative of a constant function, that's the easiest one. No, third hour actually thought the quotient rule was easier than the product rule.
Oh, well then.
All right, well, let's do the quotient rule. Take a look at the numerator of that quotient rule. What do you notice?
3x.
Oh, sorry, of the quotient rule, this box. Our formula. It looks the same as the product rule. Is it exactly the same? Oh, we got a minus in here. And then what else is different? Oh, I did flip the G in the F, didn't I? Oh. All right, that's true. And then we divide by our denominator squared, right? And the rhyme to, this one actually does rhyme. The rhyme to remember is low D high minus high D low. Draw the line and square below. So do you understand what like low D high means? No? Low means like your denominator function, like g of x. D high means the derivative of your high function, your numerator, which is like this f prime of x. Minus is the minus sign, right? High means your numerator, so f of x. D low, the derivative of the denominator. And then we draw the line and square below, square g of x. Let's do this. Okay, 3x over x plus 1. What do we do? What's the derivative? I'm going to write dy dx this time, just for the sake of... All right, low, what's our denominator function?
X plus 1.
X plus 1. D high, what's the derivative of the numerator? 3 minus high, so what's our numerator function? Times d low times the denominator derivative. What's the derivative of x plus 1? That's just a 1. Then we draw the line and we square our denominator, which is x plus 1 squared.
And then do we have to simplify that?
Well, if we do, this numerator, when we distribute the 3, we get 3x plus 3, right? And then over here, we've got the minus 3x. So this 3x is simplified to 0. And we're just left with 3 over x plus 1 quantity squared. And that's our derivative function.
And you do want us to simplify that? Or
You know, if it's easy, then sure. If you have lots of fraction exponents, then that's really up to you and your algebra skills. If you know you can do that without making a mistake, then go for it. If you're pretty sure that you'll make a mistake, then maybe just leave it as it is so I don't have to count it wrong. Cool? Cool. Is this making sense so far?
Mhm.
Do you want to try the next one on your own or do you want to do it together? Try it on your own? Try it on your own. And then we'll do 3 together. And I'll do it up here so you can check. All right. Do we have any questions at the moment? Feel okay about it? Do you want to do example 3 together? Or do you want to try this one on your own too? It's up to you and how you all are feeling. If someone wants to do it together, then tell me. Try 3 and 4 on your own, and I'll do them up here, and you can check your work, okay? And just call me over if you just need some help. I can help you out. Hmm. What'd you do for example 3? Okay, that one even with that square root of x? I'll give you all another minute to finish writing. And when you're ready to move on, go ahead and flip the page over.
Wait, I'm confused where the 2x squared went.
Oh, where the 2x squared went in number 4? That's a good question. That got brought up third hour too. So you see we have 2x squareds here, minus an x squared here. Are you okay getting to that step? Yeah?
Yeah, I have that written down right
Okay, and then just getting from here to here.
now. Oh, you should try it.
Yeah, they're like terms, so you just take the 2 minus the 1x squared. Like you have an x squared plus an x squared. That's a 2x squared minus an x squared. So all you're left with is just an x squared.
No, I was trying to factor and then I was like, getting on the wrong side.
Oh,
It's
gotcha.
okay.
Does this make sense though?
Yeah.
Any other questions? Okay, well, then if you haven't already, go ahead and flip the page. And we'll finish this last page of notes. All about the rules of derivatives. Next week, Monday will be a work day, and then kind of depending on what happens with volleyball, Wednesday might be as well. And then we're going to start talking about how the graph of the derivative function relates to the graph of the original function. Because we graphed these yesterday, right? And we kind of have an understanding of what they mean, but we definitely need to talk about it more, yeah? So that's what we'll do the rest of next week. Just more understanding derivatives. Okay, cool. Ooh, the derivative of a piecewise function. All right. To find the derivative of a piecewise function, just find the derivative of each piece. So if this is your function, our derivative function is just going to be the derivative of each piece. So what's the derivative of 3x minus 3? That's just a 3. 1x is larger than or equal to 0. And then what's the slope at the tangent line of the curve at any point of x squared plus 4x minus 3? 2x plus 4. When x is less than 0. And then the next question, does the derivative actually even exist at x equals 0? Why or why not?
Just have to read.
Is it 3x minus 3? And then x squared plus 4x minus 3? Like this? And this one is when x is less than, larger than? Greater than or equal to? 0, right? And this guy is when x is less than 0. All right. Do you, first of all, is this continuous? Is this piecewise function continuous? Yeah, because our lines meet up right here. So that's good. So remember those 4 cases when a derivative does not exist? It's like if you try to take the derivative of like a corner or of a cusp, which is basically a corner as well. Or if it's discontinuous, or what's the one I'm missing?
Vertical tangent.
Oh, vertical tangent. Do we have any of those things here? No. So does this derivative exist? Yeah, exactly. So, does the derivative exist? Yes. F of x is continuous No vertical tangent. No corner, no cusp. And what is the derivative at x equals 0? What's the slope of the line tangent to the curve at x equals 0? 3. Okay. So, yeah, just here's a note. Remember, don't forget what these derivatives mean now that we have these shortcuts to find them. Remember that the derivative is the slope of the tangent line at a single point, okay? And now, did we talk yesterday about finding higher order derivatives? We didn't? Okay. So, once you find the derivative of something, you can find the derivative again, and that'll be called the second derivative. These have applications in physics when, okay, so if I move across the room, that's like a position graph, right? If I move, like a position graph. The derivative graph would be my speed, my velocity, right? The derivative of the derivative graph, so the derivative of velocity is my acceleration. So like how much my speed is increasing by. And that's just an application. So first, some notation, because these are all new symbols. So first derivative, we know these symbols. Give me a couple. dy dx. F prime of x. We've also used y prime, right? Those are probably the most common ones that we've used. Second derivative. This one looks a little bit goofy. What is it, Megan? Oh, it is? Oh yeah, it is. As an example. I was like, Megan watches videos in her free time. This is d2y over dx squared. Kind of, doesn't really mean squared. It means second derivative. It's just a notation to show second derivative. Why do you think those little squared symbols are in different places? Like, why didn't they just write like dy squared over dx squared? What?
Because you're squaring the derivative.
This looks like you're taking the derivative and then squaring. Or of that, or you're squaring the function first. Yeah.
But we're squaring the derivative.
Well, for this one, we're only finding the second derivative. Nothing is being squared in
Well, yeah,
this.
the second derivative.
Correct. All right. So just notation to make it more clear to show this is not being squared. I don't know why they had to be exponents, but they are. Or we write f with two tallies, f double prime, I guess. I don't know how official that notation is, f double prime. I don't know the language. You call it that, I know what you mean, but second derivative. And then same with the y, we're doing tallies. These are actually Roman numerals.
Is it so on through that?
Yep, and so on. And except when we get to the fourth derivative, our Roman numeral ones get a little different. Well, I guess not. If you know what Roman numeral for 4 is, then you're good to go. And y with 3 tallies. Then our Roman numeral friends, this is f in parentheses iv of x. That's our fourth derivative. And same with y. Y parenthesis iv. That's our fourth derivative as well. But this d4y, dx4, that notation stays the same. All right, we okay with how these are notated? Okay. Oh, we have over 10 minutes left. We are speeding. Are we okay? Are we going too fast? Are we going too slow? Okay. Let's do these two examples and then we'll just call it a day. Sound good? Okay. All right, given the height above the ground function, h of t is negative 4.9 t squared plus 55 t plus 1, where t is in time and h of t is the height of the object in meters, let's find the first and second derivative, and then explain what these even mean. You ready? Okay. So, since our function is h, we'll say the derivative of h, so h tally t, h prime of t. What's negative 4.9 times 2? Negative 9.8. T, what's the derivative of 55? T? 55. All right. And then the second derivative. Y'all, this means we take the derivative of the derivative. It is just negative 9.8. Okay. Now, I didn't add labels. That's bad. So let's go back up to the derivative function and add what our label would be. Like if I were to find a value, like what would that value mean? What label would we use? Remember, this is a position function, and given the height above the ground. So this is a t squared. This is a parabola, right? It looks like this. So it's like if I threw a ball. It's the speed of the ball. And in particular, our derivative tells us the velocity of the ball. So this one is the velocity of the ball. That's what this means. And what's our label that we would use for velocity?
E per, what is it in seconds? Seconds.
Oh, we don't even know. I just said S is time. Okay.
Meters per ton.
Meters per time. Did you finish, Austin?
Wait.
Okay, that's okay. Okay, thanks for bringing it back.
Yeah.
Cool. So that means our derivative means that's the velocity of whatever object is flying through the air here, right? So now the second derivative, that's like the speed of the speed, right?
Yeah, it's like how fast the speed is changing.
It's how fast the speed is changing. Do we know who our physics friends are in this class? Is anybody in physics?
The acceleration.
Is Alexa in physics?
No, I'm not.
Alexa just knows this. Okay. Take physics class. Yes, this is the acceleration. Acceleration. And this label is either meters per second or meters per second squared. And y'all, specifically, that negative 9.8 is the force of gravity. So that means this is an object in free fall motion, so we're not like, just means the force,
You dropped it off the cliff.
yeah, kind of something like that.
Pressure down.
Well, we did, though. That's what this 55 means. This is our initial velocity. So we threw it at a force of 55. What's our label? What's that?
It's not continuous.
Correct.
It's not like a balloon where you push it down the ground.
Right. So I'm going to write, this is the gravitational pull on the object. That's only if that number is negative 9.8. Has to be like that 9.8 number is the gravitational force. All right. Is physics only a one-try course?
No, it's too bad.
2. Okay.
I was going to take it, but then I dropped it. Next year.
Next year. Next year. Okay. All right, how about this last one? Y equals 2x squared minus x. What is d2y over dx squared?
First you take the first derivative and then you take the second one.
All right, so this means second derivative, right? So first, let's find the first derivative. dy dx. You tell me. What is it? 4x minus 1. TJ seconds that. Does anybody third it? Okay.
Ethan forced it.
Ethan fourths it. Whenever we agree, we should just go around the room and say aye. There's only 8 of you. All right, let's finish this and then we can chat and kind of mess around for the last 5 minutes. All right, what is the second derivative then? What's the derivative of 4x? That's just 4. What's the third derivative? 0. What's the fourth derivative?
0.
And then going forward, they're all 0, right? All right, cool. That's it. That's it for the day.
Nice.